Hi, my name is Rick Edgman, and I'm here at Uppsala University in Sweden, visiting from Utah State University in the United States, where I am Professor of Management and Research Director for the Shingo Institute. I'm also a visiting professor on an ongoing basis at Aarhus University in Denmark, where I am Professor of Sustainability and Enterprise Performance. So today in this short session, we're going to talk about cradle to cradle and the circular economy, two related topics. So cradle to cradle, if you really want to find some good resources, you can find some terrific YouTube videos from Bill or William McDonough, McDonaugh. So he's one of the two primary people usually given credit for the creation of cradle-to-cradle processes. He, along with a guy named Michael Brungart from Germany. So McDonough is an architect, Brungart a chemist. What a difference. So let's see what we've got. Cradle to cradle and the circular economy. By the time you finish this brief session, you should be able to answer the following questions and address the sorts of issues. One, what are the differences between the so-called linear economy and the circular economy? What are the main concepts of cradle-to-cradle design in relation to biological and technical cycles and materials? What are the synergies among these? And you should be able to identify some cradle-to-cradle or / circular economy approaches in selected companies at least. So, cradle-to-cradle. Nature is inherently efficient. So when we look at cradle-to-cradle approaches, they aim to create production techniques that are essentially waste-free. That is, whenever we get to the end of something and it creates waste, that waste is used as the fuel for some future process or some next process. So for example, in company-to-company production, all material inputs and outputs are seen as either biological or technical nutrients. Biological fuel or technical fuel. Technical nutrients can be recycled or reused with no loss of quality, whereas biological nutrients can be composted or consumed. In contrast to cradle-to-cradle is so-called cradle-to-grave. Cradle-to-grave refers to companies taking responsibility for the disposal of the goods that's produced, but not necessarily returning the elements of that to service. They just dispose of the waste effectively. So this is a mindset change when you're looking at cradle-to-cradle. Business principles based on assumptions of historically of infinite natural resources and waste absorption capacity. That's how business has been done, as though we had infinite resources, and as though the waste from our processes, from our products, and so on, could just be thrown away. Okay, there's a popular slogan in the United States: throw it away, there is no away. Okay. Second, concept of multiple industries collaborating on a whole systems approach, relying on each other's outputs into inputs, is completely opposite the cult of the individual and the pioneer myth that so deeply describes historic American corporate culture. You know, Americans were pioneers. We can't afford to be pioneers in the same way now. We can't afford to act completely independently. We live in an interdependent world. We live in a systems-focused world, and we have to be able to identify and leverage those systems. Okay, and at least in the US, so-called antitrust legislation hasn't really allowed collaboration. So what we have to be able to do now is find ways to collaborate, and that's becoming easier and easier in different places based on legislation changes. What are Earth systems? Well, what is a system in the first place? It's a collection of interdependent parts. That is, if you remove any one thing from it, the rest is affected. Interdependent parts. They operate within a enclosed boundary or defined boundary. And at least for the Earth, there are four major systems. There are lots and lots of systems, but there are four major families of systems, if you will. There's the lithosphere, which deals with soil and rock, the hydrosphere, which deals with water, the biosphere, which is living organisms, and the atmosphere, which is air. And they're all related in a way that you see, for example, or interrelated, that you see in that particular graphic. The problem is that human activity is disrupting those systems in really complex ways that are difficult to understand. Now, historically, that wasn't such a problem. It wasn't such a problem because we didn't have the population mass to notice a lot of what was happening. However, we can identify human activity-driven environmental degradation going back at least 500 years. So the problem has been there. It's that the problem has grown at an alarming rate, and we're paying consequences for that now. We see that at least partially in terms of things like climate change, okay, resource depletion. Some of our precious metals, or our rare earth metals, are at critically low supplies. So you can see the electronics of the future needing to change simply because of lack of material resource availability. So what we're trying to do with Cradle to Cradle, with biomimicry, with circular economy approaches, is we're trying to get greater balance or achieve greater balance across the lithosphere, hydrosphere, biosphere, and atmosphere. So what does the circular economy do? Well, it looks more or less like this graph, which is to say that it takes raw materials, it uses those in the design, it produces things, it distributes those things are used, they're consumed, and then we repair them, if possible, but at the end of it all, we collect them. Some of what we collect can be recycled or reused. Whatever is left is waste. What we're trying to do is turn that over as many times as possible using what comes out at the end of the use environment for some future use. Some future same use if it's refurbishment, some future different use potentially. And we're trying to minimize the amount of waste that's left over. We contrast the circular economy from the linear economy. The linear economy is often described as take, make, waste, throw away. Or take, make, throw away. But we know that we have finite natural resources, so we can't afford to do that. So what we're trying to do, and we're extracting our energy from finite resources often, so we need an energy change also, which is why we see the growth in wind energy and solar energy and geothermal energy and so on, renewable resources. The circular economy, however, is a little bit different. It recognizes two particular cycles, the technical cycle and the biological cycle. So what we're trying to do in the biological cycle, the biological materials, is that we extract things, we enrich those things so that we can make things that are then consumed or used, and then we try to recover as much in the way of biological material as possible, whether that's to use as a fuel in a next process, or whether it means that it's composted and makes its way back into the earth, so to speak. On the technical side, we use our resources, we make things, okay, we use those things, we return those things, and we recover all reusable components, metals, materials, and so on, and refurbish, reuse, trying to minimize the waste that's there. So circular economy means going around and around and around and reusing and recycling as much as possible, whether it's on the technical side or on the biological side. Oh, just a second. Okay, so cradle to cradle, the circular economy looks more or less like this. What you really want to look at are the 5 criteria that are on the bottom right corner. Those are the things that are most critical to us. So we're trying to come as close as possible to fulfilling these 5 criteria. One is 100% renewable energy use. Therefore, we don't deplete any of the energy that's in the earth, for example. So in other words, you're not necessarily using coal because we use coal at a faster rate than it can be reformed. Okay. Water stewardship, clean water output, because we know water is a finite resource. Social responsibility, we want to have as much as possible a positive impact on the community socially. We would like to have a neutral or potentially even positive effect environmentally. 4, material reutilization, recyclability, compostability. So recyclability often if it's something like a technical component, compostability if it's a biological component. And material health and impact on people and the environment. This is what it looks like, for example, in the clothing industry. This would be a typical circular economy approach. So let's see what we've got here. So what we might do is we might start, let's say on the biological cycle, we'd start with plants. But oftentimes when we grow those plants, we're using pesticides, herbicides, and so on. So what we need to do is we need to be able to eliminate those toxic materials as much as possible. Why? Because they make their way into the water, they make their way into the aquifer in the earth. Once they make their way into the aquifer and so on, they make it into rivers, they make it into foods, they make it all over the place. So what you might not know is that approximately, oh gosh, what is it? I think it's approximately 40% of all deaths worldwide annually are associated with water contamination, soil contamination, and air pollution. So it's natural that as much as possible, what we want to do is minimize and, in fact, eliminate those sources of contamination. That's what part of this is about. So we have nutrients. We want to use safe nutrients, not pesticides, herbicides. So we want to eliminate toxic materials. We produce polymers. We extrude fibers. We use both organic and natural fibers. We have biodegradable fiber then. Those can be decomposed, and we use those as necessary. We combine those as necessary with organic and synthetic fabrics and metal like zippers and buttons and so forth. Okay. There are natural man-made fibers, which we would like to reduce as much as possible. Well, natural, not so bad. We want to eliminate toxic materials in the way that these things are cleaned. So as much as possible, when we're washing clothes, dyeing clothes, and so on, we want to eliminate the dyes and the bleaching. Okay. Things like rivets, buttons, zippers, we like to be able to recover or find a way not to have to use those. But we manufacture and produce our garments, and then eventually those hit end of life. And if we've done a good job, much of that is either biodegradable or there's some waste that can be used. Okay. At Puma, what does it look like at Puma? At Puma, the way that it looks, so now you have a company example. On the biological cycle, what will happen is that you have, let's say you buy this thing from Puma. You purchase something at Puma, you use it, you enjoy it. If it's on the biological side, then basically you can deposit that thing in a Puma recycle bin. From the Puma recycle bin, it gets degraded into rich nutrients. Those rich nutrients then feed the plants, which are generated into good natural resources that might be used for production in the future. Those resources go into the factory, and again, you make them into products. On the technical side, what you have is something like you purchase something at the Puma store, you use it, you enjoy it, you take it back to that Puma recycle bin, so to speak. It's broken back down into little pieces, some of which include rivets or metal or things of that sort, buttons. Those are turned into raw materials. Okay, not natural materials, but the technical materials. And they go right back into the factory where they're used to make still future garments and so on from Puma. So that's how Puma handles cradle to cradle. Okay, why is it important to look at the supply chain? Supply chain is very important, and you should follow, for example, if you want to see how these things really work, go to YouTube, find some videos on the coffee supply chain. You'll find some really interesting pieces, some of which will probably deeply disappoint you. But what happens in a cost-focused supply chain is that we usually obtain things from suppliers by focusing on cost. And so what we're trying to do is minimize our cost. Well, what suppliers do we get? So we're starting at the very top of the orange cycle, and we're working counterclockwise. We try to go to the least costly supplier, the cheapest supplier, if you will. So how does the supplier compete to get our business, to get our contracts? Answer is that they produce materials at the cheapest possible cost. Now, it can be good to have some of that pressure. That can actually force companies to take a lean approach. But on the other hand, it can also force them to cut corners or lead them to cut corners. So when you take this approach, sustainability is seen as a cost driver, not any kind of benefit. It's a cost driver. So accounts payable delays payments so that they can conserve their money because money is the focus. The suppliers underinvest in more people and new production methods because they don't have the capital. And then ultimately what happens? You have things like increasing bankruptcy and increasing supply chain risk for your customers and for the company itself. So that's sort of the cost-focused supply chain. When you're talking about the circular economy, then you're talking about the value-focused supply chain. So let's start at the top of the blue cycle, because this is where it all begins. Just as it did in the cost-focused supply chain, it begins with the procurement focus. But in this case, when you're in a value-focused supply chain, then you're focusing on value and innovation. So what does that mean? It means that those suppliers that want your business are trying to compete based on providing the most value, based on providing innovation, and so on. It's a different competition. When they do that, what is some of the value that can be added? Sustainability. So sustainability is seen as a strategic differentiator, not a cost. Finance programs secure early payments and capital for suppliers so that they can feed that back into innovation and improvement. And hence they invest in people, they invest in new production methods, and so on. And growing suppliers means lower cost and greater value for your buyers. So there's real benefit into focusing on value-focused supply chains. So that would put you at the end of this session. Hope you've learned just a little bit about cradle to cradle and a little bit about the circular economy and how they're intimately related to one another. So thanks very much, and I'll talk to you in some later segment.